Hi, this video is about exponential growth and logarithms. Well, so this new unit is on logarithms, and exponential growth and logarithms are inverses of each other. So that's one important part. All right, well, these are just exponents. And when you have a base 2 to the exponent and another base 2 to the exponent, these can just cancel. So you just get this, 3a minus 3 equals a plus 3. And then you solve that. I'm going to add this 3 to the other side. Just going to solve for a. That's all I'm doing. So I get a equals 3. You can check your work by plugging it in. Look at this. Alright, you say a is 3. Okay, well, let's see. 2, 3 times 3 minus 3 equals 2, 3 plus 3. So, 9 take away 3 is 2 to the 6th power. Because that'd be 9, take away 3, and this would be 3 plus 3 is 2 to the 6th power, and those would be equal to each other. Alright, check this out. Okay, so you need to bring any fractions up to the top. So if I want to bring this to the top, okay, let me tell you what I did. So you need to make sure that you have the same base here. So my base is 2. So I know that 2 to the 5th is equal to 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's where I'll get 2 to the 5th is 32. Alright, then I need to turn that 4 into a base 2. So 2 squared is positive 4, but if that 4 is in the bottom, you have to make it negative. I don't know if you remember the rule. If you have, this is like the general rule, to the negative 1 equals, this was for exponents, just an exponent rule. That a negative power, you put it in the denominator to make it positive. Okay, so then to finish this problem, you just get 5p equals negative 2p. And then I just get all the p's on one side. So I get, oh, well, let me fix that. I get 7p equals 0. When you divide by 7, you get 0. P equals 0. Okay, let me explain this problem. So you have to get the same base again. So you kind of have to think through this. You have to decide what number can break down to give you both 16 and the 64. And so I went to 4 as my base. So 4 squared gives me 16. And 4 to the negative 3, it has to be negative because the 64 is in the denominator. 4 to the negative 3 has to give me 4 is the same base. So now I just cancel the bases and you use this information to solve the problem. Something that you need to remember for this next part is how to rewrite logs. This is how you rewrite logs. Base, exponent, answer. Right? So 8 to the first power would equals 8. So what you need to remember is that these cancel each other. Alright. 15 to the first power is 15. 15 to the first power is 15. These would, if you have a 15 and a log of the base 15, they cancel each other. That's how exponentials and logs are inverses of each other. Okay. Okay, so if you get a problem like this, it looks really ugly. But really all you have to do is, because this is log 15 and this is log 15, I know I just have to do 15 to both sides. And 15 log base 15 cancels. So you're just left with negative 2m equals negative 3m minus 4. You solve. So when you see a problem like this, you go, oh, they have the same bases? That's awesome. I know they will just cancel if I put a 3 in front. So then I just get r minus 1 equals 3r minus 9, and I just do the algebra for that. I gotta have a better color. Minus r from both. So this was r minus 1 equals 3r minus 9. So I get 8 equals 3r, take away 1, r is 2r. R is 4. You could check your work. 4 minus 1 is 3. 3 times 4 is 12. 12, take away 9 is also 3. Check.